Have you ever wondered what makes bread rise in the oven, or how alcohol is made, or how we make yogurt? The key components behind all of these processes are microbes. Now we're going to show you these experiments that you can try at home.
So this experiment that we're doing shows the temperatures at which yeast will either be active or inactive.
You're going to need empty bottles and some water, sugar, and packets of yeast and balloons to capture the carbon dioxide.
First, what you do is that you pour out 2 tablespoons of sugar, and then you have to heat up the water, and then you just create a funnel. Carefully pour the sugar, shake it a little bit so the sugar is dissolved, and then you add a packet of yeast.
Each packet is 1/4 of an ounce.
You're adding in the yeast, which is going to feed on the sugar, and then you shake it really well for a couple of seconds, and then you just put the balloon on really quickly. First, the room temperature one is around 27 degrees Celsius, so that's roughly around 80 degrees Fahrenheit. And then you have the 44 degrees Celsius, which is around 112 degrees Fahrenheit. And then you have the 60 degrees Celsius, which is around 140 degrees Fahrenheit.
As the yeast feeds on the sugar, it releases carbon dioxide gas, which you see in the balloon.
Here at the 60 degrees Celsius, the carbon dioxide has already started being let out. And then the 44 degrees Celsius, our middle temperature. The balloon is starting to fill, but not as much as the 60 degrees Celsius. And here the room temperature one barely has any air in it. Okay, so I guess more carbon dioxide was let into the balloon, so then it was able to be inflated more. There wasn't enough heat in the room temperature to activate the yeast to consume the sugar. And then in the 60 degrees Celsius, the heat might have killed some of the yeast. So the 44 degrees Celsius was the perfect temperature.
So what we did in this experiment is we took a swab or a Q-tip, which looks like this. First, we diluted it by placing it in distilled water, and then we rubbed it on common places. We used a doorknob, and we also used the handle on the toilet in a boy's bathroom. We put the swab in a distilled water mixture, and we mixed it. And then after, we micropipetted 100 microliters, like using an eye drop. And we put it on the plate. So this is what we call a petri dish or a plate. We create a solution of nutrient agar mixed with water, and we leave it to dry on the bottom of a plate, like that. And it forms like a jelly substance, which we can use to feed the bacteria. And then we use the Q-tip to spread it out. And we left it to incubate, which is to grow. These are the results of our experiment. This one is the culture from the doorknob. And as you can see, the bacteria have grown all over the plate. And this proves that bacteria are found on the doorknob. The other one is called a urinal knob, and that's where you flush the toilet. And here are all the colonies here, and they're actually even more than what we found on the doorknob, which shows that bathrooms are very dirty. And that's why you should always wash your hands when you go to a bathroom. Bacteria is found everywhere.